heating pipework and components, part 2. So the key objectives for this part of the session, I want you all to be able to recognise where in the system we should position a pump and explain what might happen if it was fitted in the wrong place. Identify an air separator, again from a photo or a diagram, and describe its purpose in an open vented heating system. And describe how a circulating pump works, and as well as being able to recognise this from a picture. In this part of the session, we're going to look at mainly where to position the pump in a heating system to make sure that the system works as effectively as it can. We're also going to look at how we can remove air from both open venting systems and sealed systems, and how we accommodate for expansion in sealed systems. So firstly, positioning the pump. Ideally, the pump should be positioned straight after the neutral point in the system, and you might remember from the last PowerPoint, the neutral point is the cold feed, where the cold feed enters the system on an open vented system, or in a sealed system, it's actually where the expansion vessel is fitted. It's recommended for open vented systems for the cold feed in open vent to come into and out of the system within 150 mil of each other, and this is called close coupling. So we have our cold feed coming in, which is the neutral point in the system, and our open vent coming off just before that point. And then we should fit our pump immediately after the neutral point. An air separator actually is very beneficial because it's actually got connections built into it to allow the cold feed and vent pipe to be taken in and out of the system in one valve, essentially in one fitting rather than valve. And it also has the added benefit that it actually removes, it can help assist the removal of air from the system. And essentially the way it works, you've got the flow coming in from the boiler here. There's going to be some turbulence inside the valve, and the flow will continue out then to the pump, which is going to be fitted immediately after our neutral point here, which is the cold feed. And we've got a vent pipe coming off here as well. So inside this valve we should have, inside this fitting, we should have some turbulence, which will also help aid the release of any air from the system. So you can see how it all works here. We've got a flow from the boiler coming in, flow out to the pump coming out there, cold feed going in there, vent pipe coming out there. So where do we position the pump? The best place to fit it is straight after the point where it's the close coupling has occurred. So you've got flow coming out of the boiler here, going into the air separator there, cold feed coming in there, and then straight away, straight after the cold feed, we have the pump. And essentially what this does is it helps keep the system under positive pressure. So you've got everything in front of the pump would be considered to be in positive pressure, and everything behind the pump up until it reaches the cold feed would be considered to be negative pressure, because the pressure in the system changes at the cold feed. So if you fit it immediately after the cold feed, we've got positive pressure all the way around back to the cold feed, and just a very small amount of negative pressure behind the pump. You need to be careful that you don't fit the pump before the open vent, because there's a big risk there that it might then pump over. And you need to make sure that you don't fit it before the cold feed, because then it will only be positive pressure between the pump and the cold feed, and the rest of the circuit would be under negative pressure, which you're going to look at now. So if you position the pump in the wrong place, there's a risk of air being drawn into the system because it's under negative pressure. You can see, for example, here we've got the pump fitted just before the cold feed, so there's only going to be one small bit of positive pressure in here, and the rest of this is going to be negative pressure all the way back round to the cold feed just here. In this circumstance, you can see, well, actually, most of the circuit's going to be under positive pressure because it's fitted just after the cold feed. So it's going to be one little bit of negative pressure here between the pump and the cold feed. The rest is going to be under positive pressure. But the big issue with this is you've fitted the open vent just after the pump, which means that in all likelihood the water is going to be pushed up through the open vent, and it will pump over into the feed and expansion system. We're going to look at pumps now. This is a picture of a pump over here on the right hand side. It's inside there you'd have an impeller. An impeller spins round and it circulates the water around the system. These can become damaged or blocked with sludge, and so therefore we should always make sure we fit pump valves like this one here, each side of the pump, full bore pump valves so they don't open up to the full bore of the pipe, and these can be used to maintain the pump or replace the pump as required without having to drain the whole system. Inside these, they can either have a fibre washer or a rubber washer to help give it a watertight seal. Quickly going to look at auto air vents. On the left hand side here we can see the symbol here for an automatic air vent and an actual automatic air vent just here. The purpose is to automatically remove the air from the system. A good place to fit them would be any high points in the system. Particularly people often fit them just before the coil, because that's where airlocks can happen. So you see there a symbol of an auto air vent just before the coil. You'd fit it in any high points in the system really. It's particularly they can be useful for open vented or sealed systems. Very briefly look at unvented sealed systems. As we know, these are fed from the mains, the cold water supply pipe, and they deliver hot water at high pressure. They're going to have pressure gauges on them, and in the case of sealed heating systems, they'd be filled through a filling loop. Filling loop, it must be disconnected after filling, and this creates a physical break between the heating and hot water circuit. In terms of accommodating expansion in a sealed system, actually sort of in an open vented system, the expansion is taken up in the feed and expansion system. As the water heats up and expands, it will just expand up the cold feed and it will fill up the feed and expansion system. In the case of a sealed system, they would need to facilitate expansion another way, for example through the use of an expansion vessel, and you can see how this works here. It would be pumped full of air or nitrogen, and as the system water expands, heats up and expands, it would sort of push into the expansion vessel, push on the diaphragm, which would then squeeze this air cushion in here. And in sealed systems, as I mentioned right back at the start, the expansion vessel is considered to be the neutral point of the system, and ideally you'd fit the pump just shortly after that. Very briefly, we're going to look at the combi boiler. Combi boilers or combination boilers would have expansion vessels and pressure relief valves built into them. That would be 15mm, the expansion relief valve on a small boiler, most likely. And as you can see, this is an example of a filling loop here. Again, the heating side is going to be filled through the filling loop, and as soon as that system's full, you should disconnect the filling loop to create a physical barrier between the two systems. Now it is time for your task.